All right, so we're learning about solving systems of linear equations by graphing. So first thing we need to know is what a system of linear equations is. All right, a system is a set of 2 or more equations, and that's all it is. It could be 3, it could be 12, it could be 45. It's just 2 or more equations, and they have to share the same variables. Okay, so that means, like for the example we did in class today, X in our example was the number of people coming to my Christmas party, and Y was how much money it was going to cost me to cater this Christmas party. And both of those situations, X and Y meant the same thing. So in a system, it's 2 or more equations, and the variables mean the same thing in both of them. Okay? So to find solutions by graphing, so right now we're talking about graphing. To find solutions by graphing, all you do is graph each equation on the same coordinate grid, and you look for where they cross. Okay? So I take one graph. So here, let me show you. I'll show you an example here in a second. But you're gonna so like I have like one line. So say I've got 2 equations, right? So I graph the first one carefully. I graph the second one, and I look for the point where they cross. That's my solution. Now, we have different ways that we might see solutions to systems. So the solution is where or how or if those equations cross. So there are 3 things that we might see. We might see one solution, no solution, or infinite solutions, okay? So if we have one solution, which is this one, then the lines intersect and the solution has one ordered pair. So in the case of this one, well, it's like, let's just estimate. So it's about 2.5, comma, 2.75, okay? So these 2 lines cross at this point exactly, and that's the only place where they have the same answer. They call it coinciding. It's the only place they cross. If I look at a table of values in my calculator, I'll put the first equation in y1 and the second one in y2, and I look at the y1 and y2 values. I'm looking for where y1 and y2 are equal. So I will only see y1 and y2 equal in one place. So like, for example, let's say I have, okay, I've got those 2 equations. Well, let's make it a little easier than that. Let's say I've got 3x plus 5 and 6x minus 10. If I look at the table, I'm looking for a row where they're the same. And see, I see it right there at 520. So when x is 5, y1 and y2 are equal. Now, that's what I see if I have one solution. I'm only going to see one x value with matching my 1 and my 2 values. Now, if I have no solution, that means the lines don't cross because they're parallel. And what that means is, so like, for example, if I had an equation like this, remember, parallel lines have the same slope. So if I look at the table, well, if I look at the graph, I see that my 2 lines are parallel. Now, if I look at the table, what I see is that, so for example, if I look, 17 minus 15 is 2. 20 minus 15 is 5. 23 minus 15 is 18. 26 minus 15 is 11. These are all 15 apart. Every one of these is the same distance apart. That means they're never going to get any closer because they're the same distance apart. And that's how you can tell that you have 2 equations that are that have no solution in y1 and y2. If it looks like there's only one line, so for example, if I had like that, 3x plus 5 and 3x minus 10 plus 15. If I look at the graph, then I see it graphs the first line, and then look at that. It's immediately graphing the second line right on top of it, okay? And when I look at the table, all of my y1 and y2 values are exactly the same. Okay, and again, we call that infinitely many solutions. Here they call it infinite solutions, but what it means is they graph looking like the exact same line. Okay, those are the 3 kinds of solutions that we might have. Right now, we're dealing with linear systems with 2 equations only. You'll learn about more complicated ones like with 3 equations or 3 variables or quadratics and all kinds of other stuff in Algebra 2. But for this year, for Algebra 1, our systems only have 2 equations and 2 variables. All right. So that's what you're doing today. So the steps are, you graph the first equation, you graph the second equation, and you look for where they cross. They're going to cross in one of 3 ways. They'll cross in one place, no place, or every place.